In this session, we are going to solve this question, which is based on the concepts of permutation and combination. The question goes like this. A town council plans to plant 12 trees along the center of the main road, and they are selecting these trees from a garden which has a collection as below. They have hibiscus, they have jacaranda, they have oleander. Hibiscus, as you can see, are 4 different hibiscus, 9 different jacaranda and 2 different oleander. So 4, 9 and 2. Now the first part of the question goes like this. How many different sections of 12 trees can be made if there must be at least 2 of each type of tree? So first possibility could be, now see oleander are true, so you have to select those 2. I am selecting 2 hibiscus and I am selecting the rest 8 jacaranda. So if you solve with calculator, that will give me a total of 54. Second possibility could be, I am selecting 2 of oleander first. Now I am making hibiscus 3 and I am selecting remaining 7 jacaranda. That will give me 144 with calculator. The third possibility could be again 2 oleander. Now I am selecting all the 4 hibiscus and I am selecting the remaining 6 jacaranda. That will give me 84. So total, if you add up all these, you will get 54 plus 144 plus 84. So that will give me 282 ways. So these many different ways I can select trees such that at least 2 of each is selected. So this was my question number 1 over here. Moving to question number 2. Now question number 2 has a different set of library from which they are collecting trees, and in that library this is 4 again, this is now 6 and this is 2. As you can see, they already have 12 trees now, but the arrangement is different in part 1 and part 2. In part 1 they say how many different arrangements of these 12 trees can be made if the hibiscus trees have to be next to each other, the jacaranda trees have to be next to each other, and the oleander trees have to be next to each other. Means you don't have to split them, they should be all together. So let us try to create a place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now see, I am planting all the hibiscus first together. Let us make it with different colors so you understand. These are my 4 hibiscus. These are my 2, 3, 4, 5, 6 jacaranda, and these can be my 2 oleander trees. Now what I am trying to do is, I am trying to bundle them together. This is one bundle, this is second bundle, this is third bundle. So how I will make the arrangements, now you see. First I will shuffle these bundles among themselves. So 3 factorial times. The question says all these trees, all 4 hibiscus are different, they are not alike. So then we shuffle among themselves. Similarly, jacaranda, all the 6 are different, so you can arrange them in 6 factorial ways, and you can arrange the oleander 2 trees in 2 factorial ways. So this will give me a total of, very big number it is coming, 207360. You get this if you solve this with calculator. So this was my answer to part 1 of question number 2. Moving to part 2 of question number 2. Part 2. This was my part 1 of question number 2. Now here it says how many different arrangements of these 12 trees can be made if hibiscus trees are next. Hibiscus tree is next to if no hibiscus tree is next to another hibiscus tree, means the hibiscus trees are separated. See, creating a place. Now understand, whenever you have to draw such type of questions, the rest of the 8 trees you plant in such a way that there is always a gap in between for the hibiscus tree. So see, this is 1, there is a gap, 2 gap, 3 gap, 4 gap, 5 gap, 6, 7, 8. I am planting this rest of the 8 trees such there is always a gap of hibiscus trees. Possibility for hibiscus trees could be 1 over here. Don't forget this, 1 should be over here. You can always keep 1 over there, and the last after 8 number. Now see, this 8 trees other than hibiscus, you arrange them in 8 factorial ways. Out of the, how many gaps now I have for hibiscus trees, let us calculate. I have 1, 2, 3, 4, 5, 6, 7, 8 and 9. I have total 9 gaps where I can fit hibiscus trees. So in this 9 gaps, I am selecting 4 gaps because there are only 4 trees. So 9C4, all the 4 trees are different. I am arranging them in 4 factorial ways. If you try to solve this with calculator, 8 factorial times 9C4 times 4 factorial, you will get 121,927,680. So this was my answer to part 2 of question number 2. I hope you've understood this question. Thank you.